Hi there. Today's video is about the Treasury system and the user interface. Today I'll cover these four topics. First, I'll describe what is the Treasury system. Then I'll explain why we have a user interface. Then I'll do a demonstration of the user interface in the test environment. And fourth, I'll discuss the technical aspects of the project, where it lives, and how it's constructed. Here is the Ethereum blockchain. We deploy a smart contract that we call Treasury, and it's an object that lives on the Ethereum blockchain. It's fully transparent to the entire world, and it will always be there, and the logic will always run. This smart contract is designed to accept money from the Ethereum blockchain from any source, doesn't matter, and the money will simply sit in the Treasury. Smart contracts can be set up to have an owner, and we're going to establish an owner for the smart contract. Now Ether will come into the smart contract, and the owner, in some naive implementation, could just simply withdraw the money from the contract and walk away with it. Having one person in charge of a treasury is not always a good idea. So in our system, what we do is we take away the role of owner, being able to withdraw money from the contract, and instead what we do is we make the owner of the treasury, we call that person the treasurer, and we give them super user privileges, but they can't spend money out of the contract. All the treasurer is able to do is create these things called spend proposals, and a spend proposal is just a record that says who a spend would go to, how many units of currency would go, in this case Wei, and some optional external reference that the treasurer can use to refer to why the spend happened, and that would be some reference in another system. The other big job of the treasurer is to maintain a set of trustees, and the set of trustees are able to approve spend proposals, and the spend happens as soon as a majority of the trustees have issued an approval. Once more than 50% of the trustees have approved, then the spend happens and it'll go to an external address. The advantage of having this treasury system is that now we've distributed control of the treasury to a group of people who must act together. The treasurer has to issue spend proposals and make sure that they're always solvent, that the smart contract is always solvent, and the trustees have to cooperate to approve spend proposals. And anything that happens with this treasury, of course, is fully auditable on the public blockchain. So that was a pretty quick rundown of what the Treasury Smart Contract is. Next up, we're going to talk about why we need a user interface. Now for the motivation part. I'm going to begin by running Ethereum. That's Ethereum that runs in RAM and is useful for testing. And over here I'm going to run the node program, which runs JavaScripts. And I've got this JavaScript that creates a treasury. There's the smart contract address. In that same directory I've got a set of scripts, and that address is useful to be passed as an argument to some of these scripts. But this illustrates why the motivation for the UI, and that is most people aren't going to want to run to the command line and run node and run all these, script everything they want to do with their smart contracts. So it's useful for a given smart contract to provide a point and click UI, and that's what we've done with the Treasury UI. Okay, and moving on to part 3, the demonstration part. We've got test RPC, we've got some default accounts set up for testing here, and we've got our Treasury Smart Contract created. I'm just going to take the address, and over here I'm going to run NW and pass it the argument dot. Here's what the UI looks like when it comes up. In here it's got a list of all of the Ether accounts that it found when it read them from the node. You'll see those correspond to this list here. If you're running geth, this would be a list of your geth public keys. There's a balance here, how many Ether are held by this account. If we switch accounts, you can see by default they create 100 ETH. That's just what the test program does. This UI will not work right if there's no Ethereum running in the background, and it also won't do anything right until it has a smart contract address. Once we tell it the right address, it will bind to that contract. So let's just click forward to members. Oh yeah, you can see that it initialized with the balance that the smart contract holds. Prior to this demonstration, I moved this amount away into the Treasury so that we would have something to spend. This list at the top here is essentially identity. So I created this smart contract, and by default, I'm the treasurer, and my address happens to correspond to the first one in this list. If I switch to a different account, I can see that the options available to me change because this account doesn't happen to be in charge of the smart contract, or it's not a treasurer, it's not a trustee or anything. And if we go back to the treasurer account, you can see the widgets are re-enabled. Now there's a few things I can do here. Let's add a trustee. So we'll pick this second account here that was created for us. And there's various things I can do. I can add, flag, unflag, and replace trustees. But for now, let's just do an add. And the address that I specified is now in the list of trustees for this smart contract. So let's say that this person has done something we don't like. We're going to flag them. Flagging means they're not able to vote. Oh, and by the way, whenever you click do it, this is actually spending real ether. It's going to go out to the blockchain and consume gas. So that's what this little symbol here is. The ether symbol is reminding me is this is spending money. Fortunately, right now this happens to be test money and isn't real. So you can see I just flagged this account. So this trustee is not able to vote. Now let's say that it was a big misunderstanding and it's all been cleared up, and now I'm going to unflag. You can see it's unflagged the account and everything is great. Now let's say we're going to replace that account. We don't like this person anymore. This person resigned. Oops, other one. This field isn't sensitive unless this happens to be replaced. There we go. So we're going to replace this guy with this guy. And you can see it's gone out to the blockchain, updated the smart contract, and now we have this trustee. So that's all good. Now we're going to check over on how we do spends. Now since I'm still using the treasurer's account, let's set up a spend. Let's pretend that somebody's done some work for us, and this happens to be their address. So the treasurer enters in what address the spend is going to go to, how much we're going to pay this person, and presumably there's some kind of a reference in our own system. It's not stored in the blockchain, it's stored in our own books, but let's say we keep track of our invoices and this happens to be invoice like that. Okay, so we've proposed a spend. Now this page also gives us the ability to search, so we can search on any field or any combination of fields. So let's search on, see, it found the same proposal by searching on the amount. And then search with nothing will return everything in the list. We can search by who we're paying. You can have more than one spend of the same target. All right. So that's the spends. Basically, we can add and we can view. But remember, spends don't happen until or a majority of the treasurers or the trustees have voted. The treasurer is not allowed to vote. So you can see I'm the treasurer and I don't have the option to approve. But if I change to, I forget, who was it that we made the 3.4 account is the trustee. So let's switch over to 3.4 and let's go to the voting tab. And now you see the approve buttons enabled. Approve. And now there's no proposals outstanding because the spend just happened, because there was only one trustee, and that was the majority. Now in real life you'd want to set up more than one trustee so that no one person has control of all the funds. Now the spend happened. There's no spend proposals outstanding. This widget hasn't updated. However, if we rerun the UI, I'm sure that we'll get the right answer. Yep. So we just resynced and read the new balance from the blockchain. I think if you remember from before, this was where this is 9999, we had or where this is 999, we had 1,000 before, so the spend actually happened. So that is basically the UI in a nutshell. Thanks for standing by. Okay, and we're back. Just got set up here on the web. This is the fourth part and the most important part, the technical part. Here we've got a link to the GitHub repository for the code for the Treasury and the Treasury UI you just saw. Here's the smart contract sources and the various scripts that are used to run it. And the UI part that we just demonstrated is in this section here. Now we'll take a look at the files that are in here. You can see that the first thing is a JSON, and this basically just provides a pointer to index.html. So it basically says start in the index.html. And then we've got a set of scripts here that are loaded by the index. So if we take a look at the index, there's a bunch of HTML, and you'll see there's divs everywhere so that it can be skinned, and all the labels can be changed, like if you want to do internationalization. And at the bottom we just simply run all the scripts that are in this local directory. The important one is this script here, running the web3.min.js script. This is the interface to the Ethereum client, and that Ethereum client has to be running on the local host for this thing to work. But we don't provide this in the repository. This can be downloaded separately, and the instructions for how to do that are here. So that's just the files. Let's take a look at the skin. This is cascading style sheets. You can change fonts, colors, all kinds of cool stuff. And then let's go over to NW.js. So this is the executable that we use to run what is essentially a web app. Now NW is pretty cool because they provide an executable, and you can bundle the executable and all those files from the list I just showed you. You can bundle them into one executable and send that to anybody. You can download NW for your operating system. It comes for all the three majors, and you don't necessarily need the SDK if you're not going to be developing. You can get by just download the normal, and it's an easy install. Just download it, save it, and you can see in the bottom left there that it's a compressed tarball. So all you do is bust open the tarball, put it somewhere, update your path variable, and you can run it from the command line. And then what you can do is you can combine NW with the package in one folder, and then you can put that in your desktop, for example, and run it from your root window. And so that's it. Thanks for bearing with us, and we look forward to giving you more information in future videos.